Okay, looking at section 3, we're going to talk about circular and periodic functions. So when we talk about circular functions, we're talking about putting something in standard form and then going out and putting our line. Let me switch colors here. Put in this angle and opening up this angle, right? So here's our angle. Putting that angle on a standard position. And then what we want to do is we can create a triangle, right? And then with some type of special triangles that we have with a radius of 1, if I have a radius of 1 on this, it's called the unit circle. Okay, and I create this triangle that when my angle is 45 degrees in measure or 45 degrees or pi fourths if we're in radians, then the other side must be also 45, right? Because 45 plus 45 plus 90 is 180, right? And if this measure is 1, this radius of 1, that means my sides of this would be the same, right? So whatever this side length x would actually be this side length x as well, right? Because the angles are the same, so that means the opposite sides would be congruent. They would be the same measure. Okay, so when I do Pythagorean theorem, when I do x squared plus x squared, that's really just 2x squared would equal r squared, right, which is 1 squared. So then if I can go ahead and square the 1, it's 1. It's 1 and 2x squared, and I can divide by 2, and I get a half. So I have 1/2 equals x squared. I want to solve for x, find this distance right here, as well as this distance, that they're same. Square root, square root. So that's a square root of 1 on top, which equals 1. Square root of 2 on bottom, I have to rationalize it, so square root of 2 on top, and square root of 2 on top. So I get square root 2 over 2. So this side length is root 2 over 2, and this side length is root 2 over 2. Now, 2 over 2. Now, instead, these are the same still, but I'm going to change this now back to y, like we've been talking about. Our y, because this is our y-axis, so I'm going to label this side y. This is our x-axis, so I'm going to label this side x. So anytime I have a 45 degrees or a pi force, I have this special triangle going on. And like we talked about the last few days, that triangle can also be right here if I use my reference angle. Right? If I use my reference angle right there, it'd be the same triangle. Root 2 over 2, root 2 over 2, and this one would just be negative down here, and then this radius would be 1. And so all my answers for any reference angle of 45 is just root 2 over 2, root 2 over 2, and a radius of 1. So that's one special triangle that we have, a 45, 45, 90. Now, the other type of triangle that we have, let's clear that. Other type of triangle that we have is a 30 degree, and a 60 degree triangle, and a 90 degree triangle. So here, when I have a radius of 1, okay, then I want to figure out what my x is going to be and what my y is going to be. Okay, so on this one, we have to look at first an equilateral triangle, so where all the three sides are the same. So that means all angles will be the same. So they all be 60, 60, 60, right? And then if we cut this in half, right here, straight down, perpendicular, right, that would be cutting this distance in half, okay? And then it would be cutting this angle right here in half to be a 30. So now I have this 30, 60, 90. Now normally, if we label this distance of 1, this would be 1, so would this whole thing be 1. But now, this just cut that in half. So this side is 1/2. So across from the 30 is 1/2. So that y value is 1/2. Well, then I have my radius of 1 again. Now I want to find this distance right here across from the 60. So across from the 60. Well, there I can do Pythagorean theorem, right? So 1 squared is equal to 1/2 squared, which is 1/4, plus we'll go ahead and label this a y, or x squared. So then I have 1 equals 1/4 plus x squared, so subtract 1/4, subtract 1/4, and I get 3/4, right? So 3/4 is equal to x squared. Square root both sides, and square root of 3 is just square root of 3. Square root of 4 is 2, so I get this answer of root 3 over 2. So anytime I have a 30, 60, 90 triangle, my across from the 30 is 1/2, across from the 60 is root 3 over 2, and my radius is 1. Okay, so that's when all my radius is 1, which means a unit circle. So a 1 unit circle. So when I talk about the unit circle, I'm talking about with the radius of 1. And these things will happen. Okay, so with that, you could also draw another triangle, say right about here, come down, and this angle now is a 60 and this is a 30. So that means down here would be 1/2, right here would be root 3 over 2, and again my radius is 1, but I'm kind of dealing with the same triangle here. So those two triangles and those three sides are what make up our unit circle here in these answers. Okay, so here are my answers. So anytime I have a 30-degree angle, or pi/6 in radians, I get my x is root 3 over 2, as we see, and our y value is 1/2, right? And then out of 45, they're both root 2 over 2. And then at 60, we can see we get our x is 1/2, and our y is root 3 over 2, just like here, right? The only difference is up at the top, it's a 1 unit circle, so this distance is 1. That's why the y value is 1. And my x is 0 because I'm just on the y-axis there. Same thing here, except for now I'm down left, so that's -1 and a 0. And then down here, I'm at 0 and I'm down 1. So that's why it's -1. And then over here, my y value is 0 and I'm just to the right 1, because my unit circle is radius equals 1. And so I can go around the unit circle, and every one of these angles are really just some type of 30 and some type of 60 or 45, right? And then we just have our at 90, at 180, at 270, back at 360, those ones. So right here, this 150, that is really just a 30-degree angle. See, notice those are the same answers, except for since I'm to the left, cosine, or my x would be negative, right? Here, these two right here have the same answer, right? Except for here, I'm just down, so it's a negative root 3 over 2. These two have the same answer, right? Except for this one's left, so that one's negative, where this one is positive. This one right here has the same answer as this one, except for since I'm down, the y is negative. So really, it's just two triangles, a 30, 60, 60, 90, or a 45, 45, 90. So as long as you can remember these ones, you'll be able to use a reference angle to find these ones, to find these ones, and to find these ones. And then all you have to do is see which quadrant you land in to see if it's going to be positive or negative, like we practiced in 9.2. So that is how we use the unit circle.